Below is question 17. The given is RE is an altitude of triangle RST. And we have to find the measure of MN, NE, and RT. So let's find the measure of MN. NM is half the length of ST. ST is 18 plus 10, which equals 28. And half of 28 is 14. So for MN, we're going to write 14. Next is NE. NE is part of an isosceles triangle consisting of segment NS and SE. So I believe that measurement NE would be congruent with measurement SN. So I'm going to have it as 15. And RT, okay, so first let's find the measurement of MT. MT is congruent to the measurement of ME, so it's 13. And since NM, cuts segment RT in half, that means RM is also 13. And add together, RT equals 26. So I quickly paused this recording to draw the diagram. So it's number 17 tells us that L is parallel to M and M is parallel to N. So we're gonna parallel. Okay, next what we're gonna do is we're gonna find the value of, let's just start with Z, since it's in the middle. So we know that Z is equal to 54 minus 30 divided by 2. So we do that. So Z equals 24 divided by 2. And so that equals 12. Then we have to add that 30 in there. So 30. And then for Z, we get 42. Okay, next what we're going to do is we're going to find X. So for X we know we know 5x minus 4 equals 3x plus 12. We know this since 28 equals 28, so we assume all segments are congruent. So now we just do basic algebra. So minus 3x on both sides, and plus 4. So that equals 2x equals, 16? And you use division to make it x equals 8. So the lastly we want to find the value of y. So we're going to have 2y squared minus 6 equals 28. So we're going to do plus 6. So 2y squared equals 34. Divide by 2. Y squared equals 16. On the square root, you divide by the square root. Square root it. Y equals 4. So our final answers would be x equals 8, y equals 4, and z equals 42. Okay, we're gonna have to start a new page. So this is number 19 is a proof. So the given is segment PR is parallel to segment VO. segment RO is parallel to segment PV, and segment PR is congruent to segment RO. What we have to prove for this proof is that angle 1 and angle 2 are complementary. So I'm going to quickly pause this to draw the diagram. Okay, so I just quickly drew the diagram and wrote the given to begin this proof. So for the next step, I'm going to write that quadrilateral PROV is a parallelogram. Okay, so in the proof it tells us that PR is parallel to VO and that RO is parallel to PV. So we're going to write that down, and we also know that line segment PR is congruent to RO. So one of the characteristics of a parallelogram is that both pairs of opposite sides are congruent. So I'm going to write that down. Okay, so now for the third step, I'm going to write down that PB is congruent to RO. And the reason for this is that the definition of a parallelogram. So we're going to write that. So so PV is congruent to RO. So we'll just do a little double hashtag there. Okay, and the next, and another one we add in there is that PR is congruent to VO. So we'll go back over here. Okay, so step 4 is we are going to say that parallelogram PROV is a rhombus. Is a rhombus. A reason for that is all 4 sides are congruent and parallel. Okay, so the next step we're going to do in proving that this is indeed to prove the whatever we're supposed to prove. Yeah, so for step 5 we're going to put diagonals bisect and form 90-degree angles. And the reason for this is that's just definition of a rhombus. And this is the last step we're going to do. Step 6. Angle 1 is supplementary to angle 2. And that's because it's definition of an isosceles triangle. Well, there you have it. All of my problems. So